Commutativity of multiplication of rational numbers. In our earlier two videos, we have learned that addition of rational numbers is commutative, subtraction of rational numbers is not. I'll post the video links for those video tutorials in the description box below. Please watch them. In this video lecture, let's learn whether multiplication of rational numbers is commutative or not. It means if we take two rational numbers a and b, then for the rational numbers a and b, their multiplication to be commutative, it will be a times b equal to b times a. If a times b is equal to b times a, then we will say that yes, multiplication of rational numbers is commutative, otherwise not. So let's see here. We have two rational numbers, minus 8 over 9 and minus 6 over 3. First, we are going to multiply minus 8 over 9 multiplied by or into minus 6 over 3. Right? So first we multiply the numerators together, that is minus 8 times minus 6 and then 9 times 3. We have multiplication of two negative numbers, so the product will be positive. Simply 8 times 6 becomes 48 divided by 27. Right? Now let's do minus 6 over 3 into minus 8 over 9. Again, the numerators together, so minus 6 times minus 8, and this is 3 times 9. This becomes again 48 over 27. So this 48 over 27 and this is also 48 over 27. In this first example, this gets satisfied as yes, a times b is equal to b times a. Let's take another example, minus 11 over 10 and minus 5 over 3. If we first multiply minus 11 over 10 into 5 over 3, then the numerators together, minus 11 times 5, and this is 10 times 3, you get minus 55 over 30. Now let's do 5 over 3 times minus 11 over 10. So the numerators together, 5 times minus 11 and 3 into 10, you get minus 55 over 30. So minus 55 over 30 and minus 55 over 30, in both these two cases, doesn't matter whether you multiply a times b or b times a, actually we are getting the same result. So from this example and from this example, we can say that yes, multiplication of rational numbers is commutative. So addition is commutative, multiplication is commutative, but subtraction is not. Commutativity of division of rational numbers. In this video lecture, we discuss whether division of rational numbers is commutative or not. That means if we take two rational numbers a and b, then the division of rational numbers to be commutative means that a divided by b should be equal to b divided by a. If this condition gets satisfied in each and every division, then we say that yes, the division of rational numbers is commutative. And to understand this, we have taken two rational numbers here, minus 5 over 3 and minus 8 over 7. First, let's divide minus 5 over 3 divided by minus 8 over 7. Right? So what we do? We invert and multiply. So minus 5 over 3 times, this becomes 7 over minus 8. Now we know that if the minus sign is in the denominator, we have run all these things. If the minus sign is in the denominator, you can simply put this minus sign in the numerator. There will be no difference in the value. Okay. So this becomes minus 5 over 3. I'm again repeating, we have discussed all those things, so I'm not going to repeat again. This becomes minus 7 over 8. Okay. Now, if you multiply the numerators together, you get minus 5 times minus 7. And this is 3 times 8. you get 35 because we are multiplying two negative numbers. That is why we get a positive result. This is 24. Okay, so 35 or 24 is the quotient or the result of this division. Now let's divide minus 8 over 7 divided by minus 5 over 3. Now again invert and multiply, so this is minus 8 over 7 times 3 over minus 5. Now if the negative sign is in the denominator, you can simply put this negative sign with the positive with the numerator, and there will be no difference in the value, in the original value. So this is minus 8 over 7 times minus 3 over 5. So we multiply the numerators together. This is minus 8 times minus 3, and here you get 7 times 5. So the result is minus 8 times minus 3 means that you are multiplying two negative integers, therefore the result will be positive. So simply 24 over 35. So in this case we are getting 24 over 35, and here we have got 35 over 24. Clearly these two are actually not equal. So this condition doesn't get satisfied. Let's take this example. We have 100 over 9 and 5 over 2. So first divide 100 over 9 divided by 5 over 2. So what we do, invert and multiply. So this is 100 over 9 times 2 over 5, and you get 200 over 45. Multiplication of numerators together and then multiplication of denominators together. In the second one, let's take 5 over 2 divided by 100 over 9. So this becomes 5 over 2 times 9 over 100, and this is 5 times 9 divided by 2 times 100. So you get 45 over 200. So here we have 200 over 45, and here we have 45 over 200. Clearly these two are not equal. Therefore we say that the division of rational numbers is not commutative. Addition is, multiplication is not. Subtraction is not, multiplication is, division is not. Three rational numbers a, b and c, then a times b, that is first you multiply a times b, whatever result we get from this, we multiply that result with c. Okay, so a times b times c should be equal to a times b times c. That is, first you multiply b and c together, and then the result is multiplied with a. If this condition gets satisfied always, then we will say that yes, multiplication is associative for rational numbers. Can you see that here first pairing is of a and b, that is first we'll multiply a and b, then with c, the result. But here we'll first multiply b and c, and whatever result we get, we'll multiply that with a, because bracket tells the priority. Okay, now here we have a is equal to 3 over 4, b is equal to minus 5 over 6, c is equal to minus 8 over 4. First let's do for a times b and then times c. So from this one we have 3 over 4 times minus 5 over 6 times, within the bracket this one, and times minus 8 over 4, right? Now we know that whenever we multiply two rational numbers, we simply multiply the numerators together and then the denominators together. So this becomes 3 times minus 5 and 4 times 6, right? Let's use this square bracket, times minus 8 over 4. Let's put this in bracket. Now from this we get minus 15 over 24 and then times minus 8 over 4. So again we'll multiply the numerators together, that is minus 15 times minus 8, then 24 times 4, and we get from this one, we are multiplying two negative integers, it means the result will be, the product will be positive, so we don't need to mention the positive sign. 15 times 8 is 8, 5, 40 and 4, it is 120 divided by, here we get 96. So 120 over 96 is the result when we perform A times B times C. Now let's perform A times B times C if this is the case. So 3 over 4 times minus 5 over 6 times minus 8 over 4. From here we get 3 over 4 times, we multiply the numerators together, so minus 5 times minus 8 divided by 6 times 4, we get 3 over 4 times minus 5 times minus 8 means what? 40 over 24. Now again we have to multiply the numerators together, so 3 times 40 is 120 and 40 times 24 is 96. So again what we have got as a result is 120 over 96, and previously we had 120 over 96. It means that both these two are actually equal, right? So in this case, yes, this condition gets satisfied. In this example, first let's solve for A times B times C. So A is 10 over 4 times 3 over 2 and times minus 1 over 5. This becomes 10 times 3 is 30, 4 times 2 is 8 times minus 1 over 5. So 30 times minus 1 is minus 30, 8 times 5 is 40. Now let's solve for A times B times C. 10 over 4 times, let's use this one, 3 over 2 times minus 1 over 5, right? So this becomes 10 over 4 times 3 times minus 1, because we have to multiply two fractions, so we simply multiply the numerators together, we get minus 3 over 2 times 5 is 10, so we again get 10 times minus 3 is 30, 4 times 10 is 40, so minus 30 over 40 we got here from A times B times C, and minus 30 over 40 is what we get from A times B times C. Again, this condition gets satisfied in this case, in this example also. So that's why we can say that just as addition, multiplication is also associative for rational numbers. So addition is associative, subtraction is not, multiplication is associative. So what about division? For that, I'll see you in the next video. We'll discuss there. Till now, we have discussed that addition is associative for rational numbers, subtraction is not associative for rational numbers, and multiplication is associative for rational numbers. The video links to those lectures you will find in the description box below. Please watch them. In this video tutorial, we are going to discuss whether division is associative for rational numbers or not. It means that if we have three rational numbers A, B and C, then we'll say that division is associative if A divided by B then divided by C is equal to A divided by B divided by C. Now if you're getting confused, what's the difference? The difference is you have to focus on these two brackets. In this one, you first divide A with B, that is A is divided by B. Whatever result you get, you divide that result by C. Okay, so that should be equal to A divided by B divided by C. It means you first divide B by C, whatever result you get, you have to divide then A with that result, right? So if that condition gets satisfied, if this condition gets satisfied each and every time, if it's true each and every time, then we'll say that division is associative for rational numbers, or otherwise not. So in this case, first let's take for A divided by B, then divided by C. So let's solve here. This is 1 over 2 divided by 2 over 7 divided by 5 over 6. So from this one we get, since this is division, so it means invert and multiply. 7 over 2 divided by 5 over 6. This is the multiplication of two rational numbers, so we multiply the numerators together and divided by denominators, the multiplication of denominators. So 1 times 7 is 7, 2 times 2 is 4, then divided by 5 over 6 equal to, again invert and multiply, 7 over 4 times 6 over 5, and again 7 times 6 is 42 and 4 times 5 is 20. Okay, so we have found the result for A divided by B divided by C. Now let's find out for A divided by B divided by C. So what's A? A is 1 over 2 divided by, what's B? B is 2 over 7. This is divided by, what's C? C is 5 over 6. Okay, so this becomes 1 over 2 divided by, this is division, so invert and multiply, 2 over 7 times 6 over 5. This is equal to 1 over 2 divided by, this is a multiplication of two rational numbers, so 2 times 6 is 12 divided by 7 times 5 is 35. Again we have division of two rational numbers, so invert and multiply again, 1 over 2 times 35 over 12. So you get 35 over 24, right? So in the first case, that is A divided by B divided by C, we are getting 42 over 20. But in this case, A divided by B divided by C, we are getting 35 over 24. Clearly, this condition does not get satisfied in this one, right? Let's take another example. A is equal to minus 4 over 3, B is equal to minus 1 over 6, and C is equal to minus 7 over 8. Let's first find out for A divided by B divided by C. So what's A? Minus 4 over 3. What's B? Minus 1 over 6. And divided by, what's C? Minus 7 over 8. Whenever we deal with negative rational numbers, it's always good to put them within within a bracket, right? So that we don't get confused or we don't ignore this negative sign. So this is minus 4 over 3, minus 4 over 3. Inverted multiply because this is division, so this becomes, now this is minus 1 over 6. Now clearly minus 1 over 6, when we'll invert it, it will become 6 over minus 1. But we have learned that whenever your rational number is of the form p over minus q, it's actually equal to minus p over q only. That is, you can simply put this negative sign with the denominator, right? There will be no difference. We have learned all those things. So from this becomes minus 6 over 1 and then divided by minus 7 over 8. Okay. Now, in the numerator we have minus 4, in the numerator we have minus 6. Minus 4 times minus 6 means what? Plus 24, because we are multiplying two negative numbers. We don't need to mention, we don't need to write a plus sign, therefore ignore that. 24 divided by 3 times 1 is 3, then divided by minus 7 over 8. Now invert and multiply, so this is 24 over 3. If you invert this minus 7 over 8, it will become 8 over minus 7. But as we discussed here, this is exactly equal to minus 7 over 8 only, right? So times minus 8 over 7. In the numerator we have 24 times minus 8. So 24 times minus 8 means what? Your one is positive number, one is negative number. So clearly your result will have a negative number in the numerator. So this is minus 8 times 4 is 32 and 8 times 2 is 16 and 192 divided by 3 times 7 is 21, right? Now let's solve for a divided by b divided by c. If you solve it, a is minus 4 over 3 divided by b is minus 1 over 6 and c is minus 7 over 8. Okay, so this becomes minus 4 over 3 divided by minus 1 over 6. This is division, so invert and multiply, division of two rational numbers. This is minus 7 over 8. If you invert it, it will become 8 over minus 7. But as we have discussed here, it's actually minus 8 over 7 only. That is, we can put the negative sign with the numerator. Okay, now if you solve this, we get minus 4 over 3 divided by, we have minus 1 times minus 8 because we are multiplying now two rational numbers. So minus 1 times minus 8 means what? 8 divided by 6 times 7 means what? 42. So again we have division of two rational numbers, so invert and multiply. Minus 4 times 42, you will have a negative number. This is equal to 168. So minus 168 divided by 24. So from a divided by b divided by c, we are getting minus 192 over 21. But from a divided by b divided by c, we are getting minus 168 over 24. Clearly, these two are not equal. And same thing was here also. So we say that on the basis of what we have discussed, we say that division is not associative for rational numbers. Addition is, subtraction is not, multiplication is, division is not.